Nanofabrication, a process the average person isn't familiar with, but it's a process that can potentially help save lives. And a process that enables the electronic devices that you use every day.
Imagine a chip that can be held in your hand and that could be used to diagnose not only whether or not you have cancer or malaria, but could be used to impact clinical care and providing clinicians with the information that they need.
It is information that doctors can potentially access immediately, as opposed to sending samples to a lab and waiting for the results. Microchips that could facilitate such immediate access are being produced right now in the innovative Washington Nanofabrication Facility, located on the University of Washington campus in Seattle. Michael Kubase is Associate Director of the WNF. He oversees the design and manufacturing of tiny sensors, microchips, and devices that are measured in billionths of a meter.
We're enabling the research devices that will affect people in their livelihood.
They are devices that enable the next generation of information technologies. They span many disciplines and industries, from aerospace and defense to the medical research community, all being produced by the Washington Nanofabrication Facility, a place that accelerates getting ideas to the marketplace.
Our user base is very diverse. We have a lot of biotech startups that are looking at biological devices and medical device technology. We're working in the information technology space. We're working in quantum information networks, optical communications, chip-to-chip optical networks, and silicon photonics. That enables the next generation of high-speed computers and data processing.
Of particular importance is the work WNF is doing on leveraging semiconductor mass production technologies to produce advanced sensors for the medical domain.
Some of them are research devices that help with long-term studies and looking for infectious disease or looking how the pathways of cancer happen. But the other ones are more real-time sensors where we're looking at trauma situations and we're looking at creating devices that give doctors real-time information.
WNF exists to assist researchers and companies in realizing their sensing and computation solutions for unique and challenging applications.
So basically we start by making a chip, by having a concept. We sit down with our crew of engineers and help them come up with a design idea. We take that idea and transfer it into a computer model where we lay out each layer. Fabrication is basically a repetitive sequence of steps where we either add or subtract material to create the electronics that people ask for.
At WNF, commercial fabrication technology is leveraged to develop new technologies. WNF is a place where researchers from physics, biology, chemistry, and engineering come together to work on diverse problems. Daniel Ratner, a UW Associate Professor in the Department of Bioengineering, is particularly excited about a new technology he's working on called silicon photonics.
Silicon photonics is a really exciting new technology that we're focusing on here at the University of Washington. The microchip, which allows us to make calls on our cell phone, allows us to use a calculator, is a device that has many small wires that are moving electrons from point A to point B. Silicon photonics is doing that using light, thousands of times faster. And this is being used in the industry, in data centers, to move data what would otherwise be in a fire hose-sized pipe in a wire the size of a human hair.
Daniel Ratner is a foundry user at WNF. That means when he needs something made, he tells the engineers at WNF what he needs, and they make it for him.
As a bioengineer, I don't myself actually have training or background in fabrication. The WNF then provides a soup-to-nuts service where they fabricate the device at a cost I can support as an academic researcher, but also at the quality that I need to accomplish my own research aims.
Another model, the user model, allows people or companies to come in and work on the equipment by themselves.
We train them and educate them on how to use the equipment and how to develop processes. Most of our on-site users are regional companies that are looking to have a capability on in-house. We absorb a lot of the expenses of the high-priced equipment. We take care of the maintenance and we make sure that equipment's functioning. And so all they have to do is come in and use the equipment when they need to. It's a value where they don't have to make all the capital investments themselves.
Gordon Holt, Chief Science Officer for North Shore Bio, is an on-site user. He's trying to develop a chip-based molecular detection platform that will do direct sequencing of DNA and RNA.
We initially approached a series of suppliers trying to get them to make our chips for us, but it became clear that it was going to be much too costly and much too slow.
After thorough research, Gordon Holt's company chose the UW's Washington Nanofabrication Facility to do the job.
We use the fabrication facility at the University of Washington for essentially everything we're doing right now. We would probably be dead if it wasn't for the UW facility. We would have spent our money trying to find some other way to get the basic chip technology. Really, a year ago, we had nothing. We didn't even have a design for a chip, let alone chips themselves. With the UW fab facility, we were able to get spun up. It was brutal, but after about half a year, we had some functional chips. The personnel have just been superb. They've been extraordinarily good in helping us to increase our expertise as quickly as possible to push the technology quite hard. Again, our technology, our underlying technology is not that easy to make. Suppliers have told us that we could spend hundreds of thousands of dollars and expect very low or no yield. So instead, we've had to learn on our own.
WNF is also a great resource for professors who cannot afford hundreds of thousands of dollars to produce the microchips and devices they need for research.
The WNF is very important to my research. I can't do about 2/3 to 4/5 of my research without being able to fabricate my devices.
The WNF plays a significant role in attracting the best and brightest new faculty to the UW. Mei Foo is an assistant professor in 2 departments at the UW, physics and electrical engineering. She's researching the use of quantum effects for quantum computation and also for magnetic sensing.
There is no universal quantum computer that exists today, but when one is built, we expect it will essentially solve 2 things. First of all, it will solve secure communication. By the laws of quantum mechanics, you will be able to send a message securely.
The second function involves cracking or decrypting classical security in electronic communications. Professor Fu is trying to create quantum information networks using devices comprised of unconventional material.
It is possible to have someone else fabricate your devices. It's also possible to send a student away to a national lab to fabricate devices and come back. But it slows down the process so much more because what you want is an iterative process. It is never right the first time. You want your student to be able to go fabricate a device, come back to our test lab, test it, iterate, improve the device, go back and fabricate. And the ability to go back and forth is what really pushes research at a speed where it could become a technological reality.
The Washington Nanofabrication Facility is supported in part by funding from the Washington Research Foundation. Its support has been extremely valuable. The Washington Research Foundation's gift is a major component of the facility's funding, representing more than 10% of the WNF's overall budget. It enabled the facility to purchase several new pieces of equipment to ensure that users get access to the leading edge of technology. This investment has long-term and broad impact on the viability of developing new technologies in the lab. The funding sent a message to the UW leadership that the WNF is worthy of support, resulting in an upcoming renovation. WNF's user base grew by 50% over the last year with this increased demand. A new set of tools and additional space is necessary, says Carl Bohringer, director of the Washington Nanofabrication Facility.
In the future, we have ambitious plans and goals. We expect a thorough renovation of the building in the coming year. And with that renovation, we will install new tools. With these updates and new equipment in the facility, we will be able to provide much better service to our users. We will be able to run a much cleaner lab, and the yield will go up, and our users will be able to produce devices with much higher quality and better reliability.
This is all welcoming news to Mike Bragg, Dean of the UW's College of Engineering, the organization that oversees the Washington Nanofabrication Facility.
The facility is really, it's a university facility, but it's really a regional and national facility as well. These facilities are very expensive to run. They take an enormous amount of expertise, and small companies really don't have the resources. So those startup companies that we want to really encourage and who produce jobs and great products in the area need a facility like this.
The Washington Nanofabrication Facility, advancing tomorrow's solutions.